Okay, thanks for joining me. This is at THS Mr. Jones. We're going to talk about chapter 4.1 today, quadratic functions. And our objective here in this section is to recognize characteristics of graphs of quadratic functions. So we're really going to get into parabolas and the quadratic function itself. So let's just talk basically about what a polynomial is. So some polynomial, f of x, can be written like this, equals a in x n plus a n minus 1, x to the n minus 1, and I can keep going on all the way to a 2x squared plus a 1x plus a 0. Okay, so basically a polynomial is I have a string of terms here, and I have an x variable, or whatever my variable here is in my function, and I have it raised to a power. I start with the highest power and I'm going down. Now for this section, we're going to talk about quadratic functions. So a quadratic is anything that is x squared. Okay, and I could have x squared plus x plus 5. I can have some sort of combination with that. And we're going to look at these polynomials that form parabolas. Let's say I have this parabola here. Okay, and we're going to talk about characteristics of that graph right there. Okay, so there are two forms of a parabola. We have the general and we have the standard or vertex form. Okay, I tend to call this one the vertex form. The book refers to it as the standard form. Okay, so we have the general form in the ax squared plus bx plus c. Okay, now this one is really just good for finding two things. I can get x-intercepts and y-intercepts from this, but I can't really tell a whole lot about my graph. Okay, we usually use this one when we're talking about factoring and finding the zeros, and which is the x-intercept. So that one's really what that one's good for. The one we're going to get a lot of use out of is the standard or vertex form. Now, why is this one good? Well, this one I can get a couple different things. The most important thing is our vertex. And our vertex is HK. Okay, and the vertex is super important. If I go back up here to this graph, the vertex is this changing point. Okay, it's where my graph changes from decreasing to increasing, or the other way around. If I've got this graph, it changes from increasing to decreasing. That's the vertex. I can also get my line of symmetry from that. And that is x equals h. Okay, and that axis of symmetry is right here. And if I fold each half, one half onto the other, it'll land onto itself. And these two are one and the same. So let's say I talk about f of x equals x plus 1 squared minus 2. That's the exact same as writing it this way. Okay, those two are the same, and I flip-flopped sides here on accident. But these two are the same, okay? And how we go from one to the other is kind of what we're going to look at. Okay, so steps to graphing a quadratic. Number one, you're going to determine if it is opening up, which looks like that, or if it's opening down using A. Okay, if you notice here, this is the bus song. Okay, A is a vertical stretch or compressed. Negative A flips it upside down. H goes left and right. K goes up and down. So it's that song. So if you don't know that song yet, make sure you look it up here on YouTube. So using A. So if A if a is less than 0 or if a is bigger than 0, okay, if a is bigger than 0, it's going to go up. And if a is less than 0 or negative, it's going to go down. Okay. You're going to determine the vertex. So that, again, is hk, just using this h and this k. You're going to find your y-intercept, and that is when x equals 0. So you're really going to find f of 0. Okay. You're going to find x-intercepts, if any. Okay, it does not have to cross the x-axis. It does have to cross the y-axis, though. So if there are any, that's going to be f of x equals 0. So you're going to set your equation equal to 0 and solve it for x. And you need to plot at least 3 points and connect them. One of those should be the vertex. Okay, if we can get that vertex, we need to be graphing that. All right, so let's look at one here. And we'll just go step by step through it. Okay, so x minus 3 quantity squared minus 1. I know this is a quadratic equation because it is squared. Okay, so we'll start with step 1. Let's find the vertex, or determine up or down. Okay, so a is positive or negative, opens up or down. So here I have a being positive, so that tells me it's going to open up. My vertex is hk. Again, I'm just looking back up here, hk. So this is hk. So my vertex, step 2, will be 3, negative 1. Now you might notice that, oh, we're off the page here. You might notice that this is a negative 3, okay? But if we look at this, and if we remember the song, we talk about how we always use the opposite of h. The opposite of h goes left and right. So step 3 will be your y-intercept. So x equals 0. So if I plug 0 in here, so I have 0 comma 0 minus 3. That's minus 3. Squared is 9. 9 minus 1 is 8. Then step 4 was x-intercept, if any. So we'll say x minus 3 squared minus 1 equals 0. So if I add 1, x minus 3 squared equals 1. Take the square root. X minus 3 equals plus minus 1. Remember, when we take the square root in an equation, we have to have plus minus 1. So x is 3 plus minus 1. So that is 4 and 2. Okay, so I have 4, 0, and 2, 0. And step 5, plot at least 3 points and connect. So I'm going to plot all these points that I had just found. Okay, so let's plot the vertex. Okay, that's a vertex. And that vertex, like I said, is my line of symmetry. Okay, it's a vertical line. It's kind of hard to see that. It's a vertical line right there. 0, 8. I've got 4, 0, and 2, 0. Now what this does is it creates a mirror image. So you see how I have 0, 8 right here? And it's 3 units away from my axis. So I can go 3 units on the other side, and now I have 1, 2, 3, 4, 5 ordered pairs, which is excellent in order to graph that parabola. Okay. All right. How about another one? Now our goal is to be doing this stuff without a graphing calculator. You can obviously check how to do these on a graphing calculator, but we really don't want to. So I can look at this and we can say, okay, the parent function is a quadratic, so it's a parabola. It got moved right 1. It got a vertical stretch of 2. It flipped upside down, and it went down 3. So that was from chapter 3, which we can use that for this. So step 1 is determine if it's up or down. Because this is negative here, it's going to go down. Step 2 was your vertex. So I've got here and here. So that's 1, -3. Okay, so 1 minus 3. I can go ahead and graph that. Again, I'm going to put in my line of symmetry there in a different color. Step 3 was your y-intercept. So we'll plug in 0 for x. So 0 minus 1 is -1, squared is 1, times -2 is -2, minus 3 is -5. Okay, step 4, we will set it equal to 0 and solve it for x. So I'll add 3, so -2, x minus 1 squared is 3, divided by -2, x minus 1 squared equals -3/2. Okay, I'll take the square root of both sides. X minus 1 equals plus minus the square root. Okay, so I've got that negative there, which poses a problem. So 3/2 I. Okay, and when that happens, what do we notice? Well, we notice that these do not exist on this number line. Okay, so I have no x-intercepts, so we could say none. Also, think about it. If my vertex is here, and we've already found that it's opening downward, we already know that it's going to be in this kind of shape, so it cannot cross that axis. Okay, so step 5, graph at least 3 points and connect. So I've got my vertex graph, 0 minus 5. Now, how do I get my third point? Well, I'm going to take this, I'm going to reflect it over and get this one. Now, if you want more points, you can get them. Okay, how would I get them? I might plug in, let's say, -1 and see where that is. Okay, so -1 minus, so we'll have -2, -1 minus 1 squared minus 3. So -1 minus 1, that's -2 squared is 4. 4 times -2 is -8 minus 3, -11. So it's not quite on there. It'd be something like here, and I can reflect that over to here, and I've got my parabola somewhat like that. But again, these points are extra. We don't have to have those if we don't want to. As long as I have 3, I'm good. Now, what happens if I were to give you one in this form and say we need to graph it? Okay. Well, I need to get it into this vertex form. Okay. And how am I going to do that? Well, we talked about a method called completing the square, which made things factorable. So that's what we're going to do. So the first thing I want to do is complete the square on this. So I'm going to group my x's together. Okay, so that equals f of x. We'll group our x's together, and we're going to add and subtract the same number on this side. Okay, so I've got my 4 in there, and I'm going to add and subtract the same number. Now, why do I add and subtract the same number? Well, if this is 1 and this is -1, they cancel, so I get right back up to there. But my goal is to be able to make that part right there a perfect square trinomial. Okay. Well, how do I get this number in here? Well, that's b divided by 2 squared. So that's -6 divided by 2, which is -3 squared is 9. So we're going to add and subtract 9 all to this same thing. So now this becomes a perfect square. So x minus, remember the number that went here was b divided by 2. So 3 squared, and then -5. And we're done. This is now in vertex form. Okay, So we graph it. So step 1, does it open up or down? Well, this is positive, so we're going to open up. Step 2 is the vertex, so that's 3 minus 5. Step 3 is the y-intercept, so we'll plug in 0. Now look up here, if I plug in 0, this goes away and this goes away, so I'm left with 4. 0, 4. That's why this one's really good for the y-intercept. And then the x-intercept, so 4, we're going to set it equal to 0. So if I go back up this one, x squared minus 6x plus 4 equals 0. Okay, so can I factor this? Factors of 4 that add to 6, there are none. Okay, now we talked about doing this one by square root. Okay, so if I have x minus 3 squared minus 5 equals 0, we'll add 5. So x minus 3 squared, 5, square root, x minus 3 equals plus minus 5, radical 5, add 3. So x equals 3 plus minus square root of 5. Okay. So my x-intercepts are 3 plus radical 5, comma 0, and 3 minus radical 5, comma 0. Okay. So now I need to plug in all, or graph my ordered pairs. So I've got the vertex at 3 minus 5. Okay, and I like to graph my axis of symmetry. I have 0, 4. Again, I'm 1, 2, 3 away, 1, 2, 3 away. Okay, and we want to know where it crosses this x-axis. So I might have to punch these two into the graphing calculator to get an approximate number. So this one is about 5.24, and this one is 0.76. So let's see, 3, 4, 5 and a quarter about, and 3/4. So we're somewhere about like that. Okay. Now remember when we did the song, I wasn't super worried about getting exact. Now I want exact points. Okay, we have to have at least 3 exact points. Okay, so let's try another one here. Now you'll notice, okay, I've got to complete the square again. But you'll notice here with these x's, I have a greatest common factor. So I'm going to factor that out. Oops. Okay, so we went ahead and pulled that number out. Now, how do I know what goes in here? In order to complete the square, this needs to be a 1, so that's why we kind of factored that out. So I take b divided by 2 squared. So that's negative 2 divided by 2 squared, so that's a 1. Now, when I come out here, I have to remember to multiply it by this minus 3 in front. Okay, so you have 1 times negative 3 is minus 3. And in order for that to cancel, I have to, so I have 1 times negative 3, which is minus 3. In order for that to cancel, this right here has to be a plus 3. Okay, or you could have put a minus 3 here, and it made it positive with that sign right there. Okay, so just make sure that those are canceling out. And I can distribute this in. Negative 3 times 1 is minus 3. Minus 3 plus 3 goes away. Okay, so now our goal of this being able to factor, that's 5 right there, it comes true. So I have x minus b over 2 is 1. So there we are. So does it open up or down? Well, that's negative, so we're going to open down. 2 is the vertex. That's here and here. So that's 1, 5. 3 is the y-intercept. Again, I like to come back up here. That cancels, you get 2. 0, 2. 4 is the x-intercept. So we'll just set that equal to 0. So minus 3x minus 1 squared plus 5 equals 0. So minus 5, negative 3, x minus 1 squared equals minus 5, divided by minus 3. So x minus 1 squared equals 5/3 square roots. So we have x minus 1 equals plus minus radical 5/3 and add 1 over. So x equals 1 plus minus square root of 5/3. That's a little bit nasty. Okay. So again, you might need to put that into the calculator to get rid of that. And we could probably reduce this fraction or get it in the proper form. That's the same as square root of 5 over square root of 3, which I can't have that on the bottom. So we multiply the top and the bottom and you get radical 15 over 3. So I still got that plus minus 1 in the front. So I have 1 plus radical 15 over 3, comma 0, and 1 minus radical 15 over 3, comma 0. Again, you're going to have to put those into the calculator to figure out where it is on your graph. So I'm not worried about going that far. But if you got this right here, that's pretty good. So 1, 5. That's the vertex. Here's my axis of symmetry. It's opening down, so we're down here somewhere. I got 0, 2. I'll go ahead and reflect that one over. And I'm at 0. If you put these into the calculator, you got 2.3. So 1, 2.3. And you have minus 1/3. So there and there. Okay. So these can get super difficult finding these x-intercepts, but we've already found x-intercepts before. So it shouldn't be totally new. Okay, so how to find the vertex of a parabola. We've talked about how to do this briefly. It was on your test just the other day. So remember, this vertex is this changing point right here. I want to know, how can I find that? Okay, well, if it crosses the x-axis, okay, let's say it crosses here and here, the x, or the vertex, is halfway between those two. Okay, so if you can get this x coordinate right here, I can just plug it in and find the y. But the hard part is, if it doesn't cross this x-axis, that's when I use this. Okay, so the x value will be negative b over 2a, and then I plug that in to figure out what y is. Now, you might recognize where that comes from if I do this. Okay, now let's say I get rid of this part, the discriminant. Well, I've got negative b over 2a. Okay. So a lot of times you might see the quadratic formula written like this. Okay, you might see it somewhere like that. And this will give you the x coordinate of your vertex. And this will, you can talk about that maybe in calculus or something about what that meaning is right there. That's kind of more than what we're going to look at right now. Okay, so graph the function. Okay, so we're still going to go through the steps, but instead of completing the square, we're going to go through a little bit different method. So number 1, Okay, we'll look to see if it opens up or down. So I still look at this leading term, okay, and we'll say it opens down. Step 2, we're going to find the vertex. So that's negative b over 2a, comma f of negative b over 2a. So remember, this is a, b, c. So I have negative 4 over 2 times negative 2. And f of negative 4 over 2 negative 2. Okay, so this is minus 4. Minus 4 minus 4 is 1. Okay, and then if I plug 1 into the function, remember this is x, I'll plug 1 in here. So negative 2, 1 squared plus 4 times 1 plus 5. So this is minus 2 plus 4 plus 5. So that is 7. So there's my vertex. So I'll go 1, 7. You got your axis of symmetry there. Okay. So now I need some additional points. Okay. The easiest one to find from this form is your y-intercept. So this goes away, and I got 5. So 1, 2, 3, 4, 5. And I'll reflect that over. Okay, so that's step 3 is your y-intercept. So what do we say that was? 0, 5. Okay, so there's my 3 points. If you want to go ahead and find the x-intercept, you can. Sometimes it'll be tricky, especially if it's like this. They're going to be a little bit tricky. But I can also just plug in negative 1. Okay, if I plug in negative 1, okay, let's see, that's 1, so that's minus 2, minus 4, plus 5. So plug in negative 1, you get minus 1. So negative 1, negative 1. So negative 1, we're here. And if I reflect that over, I'm here. So then there is your parabola. Okay. So vertex is a must. We're going to find that either way. Okay. And from there, we just kind of mirror image everything on both sides. Let's sort of start by this question. I love these questions. They're really good for some higher order thinking. Okay, so find the quadratic equation with vertex of 3, 4 and goes through point 2, 3. Okay. I want a parabola that does that. Okay, so here's this mirror image. Okay, it came over here somewhere, so probably looking at something like that. So we have the vertex. So I'm going to use the vertex form. So f of x equals ax minus h squared plus k. Okay. So kind of like when we did the line and we found the equation of the line that went through these points. This is very similar, except now it's a quadratic. So I start with a different equation. So I know the vertex is 3, 4. Okay, so a, that's minus 3 plus 4 squared. Okay, but I do not know what a is, but I have an x and a y. So I'm going to plug in x, which was 2. I'm going to plug in y, which was 3. And now I can solve for that a value. I can solve for how much is this shrunk or compressed vertically or to the x-axis. So 3 equals a minus 1 squared plus 4. If we square that, that's 1. So minus 4 minus 4 minus 1. So a equals minus 1 because this was 1. Okay. So then I'll plug it back in. So I have f of x equals minus 1 x minus 3 squared plus 4. Okay. So we really want to practice that. Okay. Again, I can change these vertexes to any number. Let's say the vertex is -3, -5, and point -2, -4. Okay, so if f of x equals a x minus h squared plus k. Okay, so this is h. So I have a plus 3 now, squared minus 5. I'll plug in x and y. So this is -4 equals a minus 2 plus. Okay, so now I can solve this for a. So I'll add 5 plus 5, so that's 1 equals a. And then -2 plus 3 is 1. 1 squared is 1, so a equals 1. Not always will it be that. You might have to divide by some number. It just happens that these two that I made up work that way. So f of x equals a, so 1 x plus 3 squared minus 5. Okay. And then you're done. Okay, so a company produces motorcycles, has a daily production cost of that, where C is the cost in dollars to manufacture the motorcycle, X is the number of motorcycles produced, how many motorcycles can be produced each day to minimize the cost of each motorcycle. What is the corresponding minimum cost? Okay, so I really want to find the vertex here. Okay, so we can do this one on a graphing calculator to kind of speed up the process here. And you will want to know how to do this. So if I clear some of this out, I have 2,000 minus 15x plus 0.05 x squared. And if I graph it, okay, it probably won't show up, okay, because look at this, my y-intercept is 2,000. So I need to change my window. I might change it -50, 300, we'll go by 25s. And it just takes a little bit of time to figure out your scaling on all this. And think about the actual word problem and what's going on. Okay, now to find the minimum here, okay, the minimum will be my vertex. So I'll hit second calculate, minimum, go to the left of it, go to the right of it, and you'll notice that my vertex is about 150, 875. Okay, now what does that mean? So this is x, this is y. Okay, so x is the number of motorcycles. So when they make 150 motorcycles, the cost is 875. So the minimum cost per motorcycle will be $875. Okay, they cannot charge anything less than that. So how many motorcycles can the production in order to minimize the cost of each? Okay. The minimum cost will be 875 and they'll have to make 150. Okay, so you just bought a puppy and you want to fence in an area in your backyard for her. You buy 100 linear feet of fence from Lowe's. Now decide to make a rectangular fence in fenced area in a backyard attached to the house. Determine the dimensions of the rectangle pen that will maximize the area in which your puppy may roam. What is the maximum area of the rectangular pen? Okay, so I've got my house and I've got my pen back here. It will be attached to the house. Okay, I have a total of 100 linear feet. So this is x and this is x. This right here will be 100 minus 2x. Okay, so that deals with the perimeter and the linear feet. So if I take the area, will be x times 100 minus 2x, okay, and I want to maximize that. So if I graph that, and if I graph it, okay, there's my parabola right there. Now we're going to find the maximum so go to the left, go to the right. So I have my graph here. The maximum here is 25, comma 1 to 50. Okay, so this length is now 25 and 25, and this one's going to be 50. So the maximum area I can get is 1,250 with the dimensions of 25 by 50. Okay, using quadratic modeling. Okay. All right, last one. The path of a particular pot follows the quadratic function right there, where h of x is the height of the ball in yards and x corresponds to the horizontal distance in yards. Assume x equals 1 corresponds to the midfield 50-yard line. For example, x equals minus 20 corresponds to the punter's own 30-yard line, where x 20 corresponds to the other team's 30-yard line. Find the maximum height the ball achieves. Okay, so again, we're just graphing this in the calculator. Negative 1/8 x minus 5 squared plus 50. Okay, so you can kind of see it right down here. So we will zoom in. Too far. Zoom out a little bit. Okay, there we can kind of see what's going on. Okay, so find the maximum height. So we're going to calculate maximum. So we're on the left, and we'll go on the right. And the maximum is at 3.4, comma 4968. Okay. So what is the maximum height? That's about 50 yards or 150 feet. It's actually 48.6, but we're a little bit off. It's not quite at the vertex there. Okay, find the horizontal distance the ball covers. Okay, so if he starts kicking here and ends kicking here, we need to know the x-intercept. So I can find that from here too. So if I calculate the 0, okay, if I come over here and get on the left side of that 0, right side of that 0, it'll tell me that x is minus 15. And x is, we got to go to the other side, but not intersection. We're going to go all the way over there to the left and right of this 0. And it's nice, you can just kind of watch your numbers go up and down here. So enter, and we'll go to the right side of it, enter, enter. So 25. So that covers a total of 40 yards. So his punt goes 50 yards high and it goes 40 yards long. Okay. So we can do this on the graphing calculator to check our solution. We can do it by hand, doing it this way. Okay. So the next day in class, you will need to have started on this, and you will have time to ask me about some of these during the class time before we take our quiz. Okay. As always, thank you very much for watching. Make sure you give me a like and subscribe. Any comments, just go ahead and list them below. This is that THS Mr. Jones signing out.